Three types of levers. Levers are among the most important mechanisms the human body uses to move, lift, and apply force. This video will review the three types of levers found in different parts of the body: first-class levers, second-class levers, and third-class levers. In mechanical terms, a lever consists of a rigid bar or beam that is supported at a pivot point known as the axis. There are two essential components that make up every lever. One is the effort arm. The effort arm is the distance between the axis and the point where the effort force is applied. And the second is the resistance arm, which is the distance between the axis and the point where the resistance force is applied. When an object is in equilibrium, the product of the applied force and its distance from the pivot point, that is, the force arm, also known as the effort arm, is equal to the product of the resistance force and its distance from the pivot point, the resistance arm. Simply put, the equation for equilibrium is force times force arm equals resistance times resistance arm. The position of the forces in a lever determine its mechanical advantage. In other words, the location of the effort force and the resistance force in relation to the axis affects how much mechanical advantage the lever provides. Let's review the three classes of levers. First-class levers. The axis is located between the weight, the resistance, and the force. The mechanical advantage of a lever can be measured as greater than or less than 1, depending on whether the length of the effort arm is greater than, equal to, or less than the length of the resistance arm. In other words, if the effort arm is longer than the resistance arm, the lever will provide a mechanical advantage greater than 1. But if the effort arm is shorter than the resistance arm, the lever will provide a mechanical advantage of less than 1. An example of a first-class lever is the atlanto-occipital joint located between the head and the first vertebra. In this joint, we can see that the weight, resistance, is the head, the axis is the joint, and the force can come from any of the posterior muscles attached to the skull, such as the trapezius. Second-class levers. In a second-class lever, the weight, resistance, lies between the axis and the force. Due to the shorter resistance arm, the mechanical advantage in a second-class lever is always greater than 1. However, the effort must travel a greater distance than the resistance, therefore sacrificing a range of motion for force. Second-class levers are not common in the human body due to the close proximity of the muscle insertion points to joint movements, which limit their use in a lever system. An example of a second-class lever can be found in the ankle joint when standing on the tips of the toes. We can see that in this case, the axis is formed by the metatarsal phalangeal joints. The resistance is the weight of the body, and the force is applied to the heel by the gastrocnemius and soleus muscles through the Achilles tendon. Third-class levers. The human body commonly utilizes third-class levers where the force is applied between the resistance and the axis. Since the effort arm is always shorter than the resistance arm in a third-class lever, a greater amount of force is required to move the weight, but it will travel a greater distance. As a result, the mechanical advantage of a third-class lever is always less than 1. An example of a third-class lever can be seen in the elbow joint. The elbow joint is the axis. The resistance, weight, is the forearm, the wrist, the hand, or the dumbbell. The biceps muscle applies a force that pulls the weight and flexes the elbow. In summary, there are three types of levers: first-class levers, second-class levers, and third-class levers, all found in different parts of the body. A few examples of these levers are the atlanto-occipital joint for first-class levers, the ankle joint for second-class levers, and the elbow joint for third-class levers. Using these levers enables us to benefit from greater movement with more power than would otherwise be possible.